I'm going to show you how to graph what's called piecewise functions. And this you haven't seen before, but something that looks like this, where you have basically two lines, it's called a piecewise function. And there's a little bit of decision making involved. You use the top rule for any x values that are less than -2, and in this case you use the bottom rule for those x values greater than or equal to -2. So whenever I don't know what a function is going to look like, I do a t-chart. So let's see what happens. So if x is -4, notice that's a number less than -2, so I'm going to use this rule. -4 plus 5 is 1. If I plug in a -3, again I'm using the top rule, that's going to give me a 2. If I plug in -2.5, again the top rule, 2.5. -2.01, again that's still less than -2. So -2.01 plus 5 is going to give me, well, I know it's going to be something pretty close to a +3, but in fact it's going to be 2.99. Same thing over here. This is -2.001 plus 5. It's going to be pretty close to 3, but it's going to be 2.999. So if I go and graph those, here's what we have. We have the ordered pair -4, 1, 1, 2, 3, 4, 1, -3, 2, -2.5, 2.5, so something like right there. Let me fix this. -4, 1, 1, 2, 3, 4, 1, -3, 1, 2, 3 is at 2, -2.5 is at 2.5, so right around there, and -2.01 is about 3, so it looks like we're going to have a line, and we're going to come right up to this point. It looks like we're almost at the ordered pair, -2, 3, but I can't use that yet. So now let's actually plug in a -2 and see what happens. I'm going to use this rule because x is equal to -2, so -2 times another -2 is +4 minus 1, so that in fact gives me a 3. So in fact I do have the ordered pair -2, 3. If I plug in -1 in, that's going to give me +2 minus 1, which is 1, so I have the ordered pair -1, 1. I have the ordered pair 0, -1. I have the ordered pair 1. Again, I'm using that, so that's -2. Minus 1 is -3. So I have the ordered pair 1, -3. And so now I know this part of the graph is again going to be linear. It kind of makes sense. It's a line. Y-intercept is -1. Slope is -2. So my piecewise graph is going to look like this. It's a little bit strange. Let's look at the next one. So again, I have some decision making. If I plug 3 in for x, I'm going to use the top function because 3 is greater than or equal to 1, and that's going to give us a 7. If we plug in a 2, that gives us a 5. If we plug in a 1, that gives us a 3. So as far as these ordered pairs are concerned, so for x greater than or equal to 1, I have the ordered pair 1, 3. I have 2, 5. I have 3, 7. And it's not a surprise. Here I have a linear function, slope of 2, y-intercept of 1. If I could extend that, looks like my y-intercept would be 1. Let's graph the other part. If I plug in 0.9999999, well, I'm going to have to use the bottom function. And that's going to give me roughly, I'm going to say 0.5. Minus 3 is -2.5. So over here, when I'm almost at 1, my output value is right around over there. I'm going to try something else. If I plug in a 0, that gives me a -3. If I plug in a -1, that's going to give me, in fact, I'm going to plug in a -2. That's going to give me -1 minus 3 is -4. So I have the ordered pair -2, 1, 2, 3, 4. And I know this is also going to be a line. It's going to have a slope of 1/2. But here's the thing. Here's the thing. When x is equal to 0.99999, again, I said I was just about -2.5. I'm going to put a big open circle there because, in fact, when x is equal to 1, this is my output, not that. I'm going to make that look open. Okay, so notice for piecewise function, they might be continuous, and maybe they're not. They're just kind of strange-looking functions.